Alright, so this week in CAD we've got the drive system fully CAD'd up, and most of our time was dedicated on our intake system, which we designed this gearbox right here to drive both the floor collector as well as the internal elevator. We've also determined the optimal size for the hopper inside of the robot, and we've also got some very general fixes.
In week 1, we started prototyping a gear collection system. Basically, the gear will fall in, and then when we want to place it on the spring, these two flaps will fall apart. Gear will fall onto the spring, and then our robot will be able to drive away.
So during week 1, we worked with our hangar prototype. We actually took stuff from our main robot in the 2016 season and modified it a little bit to work with the rope this year. We also worked on a high goal shooter. We are working with stationary gear holders, so the gear will slide out directly into it, and then we just drive up to the airship and put it right on, and the pilot pulls it out. And we have also been working with agitators to feed shooters from our hopper.
It's week 1 here, and we've been prototyping multiple different ways to shoot into the high goal. We've been met with 2 challenges, and those are to feed the balls into the shooter and to accurately shoot into the high goal. Prototypes to feed the balls into the shooter include an indexer that would be similar to that used in paintball shooters. It would look like a dish that has multiple balls or circles cut into it, and the balls would be gravity fed into these holes and filtered into a single file line to be then shot in through the shooter. Another prototype is a revolving 6-shooter mechanism that has balls that are gravity fed into the shooter and rotates and shoots in bursts to increase efficiency. So once balls are fed into the shooter, we want to shoot them accurately into the high goal. So originally we had a flywheel shooter that just shoots with one wheel and shoots directly into the high goal. We later added another wheel to increase accuracy and prevent balls from flying out of the shooter in a different angle than we want them to be. In addition to this, we also added a way to adjust the angle of the shooter during prototyping. However, after we mounted it to the side of the basin in order to maintain the correct angle.
On week 2 so far, we have been working on our jumper prototype and improving that. We've been working with our West Coast Drive prototype, and we've begun construction with R1. So with our jumper prototype, we have added a sort of shaft right here with a screw in it. So as this rotates and forces balls in, this can raise with a window motor in the bottom, and it will push balls into here, about 45 balls in 5 seconds.
So this is our West Coast Drive. Right now they are working on fixing the encoders, so they're just trying it out on different motors. Also, we've been having problems with the wires, and we're trying to fix that. And we hope to fix many problems with the robot and be ready for the competition. We also strive to drive for 30 to 45 minutes a day, so we could be ready for competition.
In week 2, we started to combine 2 different systems that we have, such as the gear collector and the fuel collector, and we built this wooden chassis to better understand the amount of space we'll be working with during the competition season and on our final robot.
So here on week 2, we have been working on our new dumper. At the beginning of the week, we decided to switch from prototyping high goal shooters to a low goal dumper. We have also worked on our West Coast Drive construction and drive practice with that. We try to get 30 to 45 minutes a day, and then we are also beginning our R1 chassis build.
To start off week 3, our PR team has been working hard on making t-shirts and the chairman's essay. You can see the t-shirts now. They have different just ideas, creativity all the students have made to show off their interest in this year's game. But if you go to the chairman's essay, you can see how the team has been editing and just contributing to the essay in general just to make sure it's perfect for this year's judges. But if we go over to the design team, we can see they've been working extremely hard on making sure the CAD model is perfect for this year, for this week, we've made new gearboxes, a rope climber, we've updated just parts in general, and we're still making parts for the manufacturing team to assemble. And if we talk about Logan and the scouting team, he's worked on super scouting, he's modified the basic database for scouting, and we've discussed strategy overall for the entire team. And now we're going to go to the field and see what they're up to. So, to start off the manufacturing sub-team, they've been working hard on exercising the robot and getting all the drive practice in so the drivers and the robot are experienced for competitions. The design team has been feeding parts to the manufacturing team to assign more parts to build for R1, and they've been training new members on the mill and just other heavy machinery like the lathe. And if we go into the electronics room, they've been working hard on programming new motors and switches for R1. They've been working hard on making sure the autonomous works with encoders and gyros. And they've been working on more complex functions like a dumper, a pickup, climber, scoring rollers, and an electronic board, and just making sure that R1 will work with the new code.
So this week in design, we've been mainly focusing on drawings for the manufacturing team. We've also made some additions of a false wall on the back of the hopper and round rollers for the idle rollers on the pickup system, as well as through troubleshooting on the 3D printer, we've figured out that it's just a cartridge problem, and now the 3D printer is perfectly functioning.
This is week 4 of manufacturing. We've added the plywood borders to the robot as well as electrical board. We've made some minor adjustments to the gear intake, as well as added a flap to help the ball intake. We've also readjusted the bands to a proper length to maximize efficiency for getting the balls into the hopper.
This week, the electronics and programming sub-teams have some good things cooking. Want to comment?
Well, on the programming sub-team, we have coded for 6 autonomous routines, and by the end of build season, we hope to have 9 for each side of the field. That'll total up to 18 autonomous routines.
We're already wiring R1 as we speak. We're really excited for the future of this week, and we hope it's going to be a really good season. All right? We're excited, we're young, and hey, we're ready for anything.
So as of week 5 on design, we've made some major changes to the robot, some including adding bands for the intake system, designing a gearbox for the floor lift, adding a hopper support bar to the back of the robot for weight purposes, adding the electronics boards on the side of the robot, and also changing the texture of the wheels to match the robot out in the machine shop. Also, we've finished the 3D model of the camera mount that is going to go on our competition robot, as well as a window motor adapter since it is no longer in production.
Last week we worked on Chairman's and we finalized it and we submitted it on time. We also finalized the Woody Flowers and submitted that on time, and we practiced and prepared for the CDR presentation.
Hello, I'm Trevor Ashley. I'm part of the Cyberblue Robotics team, and I am part of the manufacturing subdivision. And last week we took part in building parts for R2. We had R1 drive practice. We made improvements to R1. We prepared for the CDR, and we were training more of the freshmen on machines.
It's been another exciting week in programming and electronics. Would you like to tell them a little bit about what we've been doing in programming?
I would enjoy doing that. So this week for the programming sub-team, we have coded for LED lights for our robot. So now when we hit a button on the gamepad, it will turn on the corresponding light color. Adam, would you like to fill them in on the electronics?
I would love to. On the electronic side, we've looked at current and voltage draws to better determine which systems are using the most energy on our robot, and hopefully we can maximize efficiency. Something else that we want to be doing this year is performance trending, where after each match we collect data, and then we're better to accurately see when we need to replace parts before they break down. We're really excited about our new performance trending, and we hope that that will carry us to new heights in 2017.
Animation.